So as I mentioned before, I'm skipping chapter 7, statistics, to do chapter 8, probability, because I think it works better with the other things we've been doing. So we started off with fractions. We moved to decimal fractions. In with the decimal fractions were ratios, proportions, and percents. And probability at its core is a ratio. And often we express that ratio as a percent. So we're just going to explore a few ideas in probability. Probability is a pretty complicated subject, and you can take multiple courses in it at a college. We only offer a partial one here at BMCC in addition to this, but it's wicked cool stuff, and it's involved in our lives all over the place. So we're just gonna jump in and see what we can do with it. So this is chapter 8. Probability. So I'd just like you to think about two things right now. An example of probability, any example you can think of, maybe directly relevant to your life, and maybe just some idea about probability. And then what does the word probability mean? So before I start throwing out my ideas about it, I just want to get some feedback from you all about what you have in your head about when you hear the word probability, what does it mean and what's an example? So think for a sec, write down an example of a probability situation. And then what does probability mean? I'm just going to write down an example I just thought of. So there's a chance that I will ride my bike tomorrow. We often use the word chance synonymously with probability. All right, so I got one thing, an example in the chat. And if somebody has wrote down an idea they think is interesting, feel free to speak. I'll be quiet for a moment or throw it in the chat also. Hoping you'll all play along with me today and come up with some ideas to share.
How about there's a chance that my teenager will drive me crazy?
Oh, that's a good one, yes. I have a couple of teenagers. There we go. Okay, we have 7 of us here, and so far I have 3 ideas. I'm waiting for 4 more. So if the rest of you could come up with something either on voice or chat, please share. That's a great one. There's a chance my dog might get into the trash. Yes.
Mine too, Bianca.
Well, beg for food. Yeah, there we go. I have a cat who will cry if you don't throw her cat food at her so she can chase it. Let's put these down. This is fun, isn't it? Come on. Thanks for playing. There's a chance.
Way to be positive, Jimmy.
Yeah, Jimmy, there's a chance I'll get an A on this math exam. Yes. Thank you all. Now we're rolling. Okay, so we got a few different examples here. And when we speak, I think it's more likely we use the word chance, right? That's a more common word than probability. There's a chance that my brother will not do his own laundry. No doubt. Oh my gosh. Trouble. So there's all these things in our life and we're like, man, I hope this happens. And when I hope something happens, it might happen, right? But it might not happen. So sometimes hope is a signal that we're thinking probabilistically. So these ideas of hope and chance and likelihood and probability, they're all the same idea, and they're all a belief, in my opinion. So earlier, let's see, someone wrote, and hey, Adelie, how likely something is to happen. Yeah, so it's a chance something will happen, it's how likely something will happen. And so what we have to do is we have to figure out how to measure these things. In general, I think we can sum up probability in the following way. It's a measurement of our belief that something will or will not happen. So that's the general way we all use the idea of hope, probability, chance, likely. And often when we say likely, I think that's more often it will happen than not happen. Right? So we use some words with a little bit more clarity than others. So chance could be anything. I think most people believe that. So the idea of chance, anything is possible. We use the word likely a lot when we're thinking probabilistically. And most people, I believe, the idea of likely is more often will happen than not. So for example, last year, if you asked me, hey Gary, are you gonna bike tomorrow? I would have definitely said likely. There's more of a chance I will bike than not bike. As far as any of these chance or likely, it's all references to probability. And one thing for sure we can say about probability, because there's much that's very unknown about probability, is that probabilities have to live somewhere between 100%, it's happening or it happened, and 0%, no way that can happen. 100% as a number we learned before is a 1, and 0% is a 0. So probabilities live between 0 and 1. You can't have a probability less than 0. 0 means it cannot, did not, will not happen. 1 means it happened, it will happen with absolute certainty. So that's an important thing to know about probabilities. So then what I'm thinking about likely here, something is likely if the probability of it happening is more than 50%. Right? as a decimal. So that's the way I think about the word likely. And I think most people, when they say the word likely, that's kind of what they're thinking. Okay, so the trick is that we have to come to some terms on is how do we measure this belief about situations? And some are easily measurable and some are not. So just an example of some easily measurable things. I'm going to switch cameras here. Okay, so I threw out a bunch of things here, and so let's simplify the space and look at a coin for a moment. So here I have a dime, and it's got the tail side, and it's got the head side. And I can flip it. I'm flipping it in my hand, just trying to roll it over. And it's a tail that time right there. Maybe you can see that. Then I'm trying to flip it again in the camera's range, but apparently I'm incapable to hit the camera. Another tail, and then I flip it again. Oh my gosh, it's another tail, and I flip it again. Oh, I got a head that time. See that there? So as far as a coin goes, I think there's one option head and another option tail there. You know, maybe it could stand on its edge, but I can't make it do that, so it's unlikely to flip and land that way. So we assume there are only two options. I have a dice here, and my dice has sides 1, 2, 3, 4, 5, and 6. And I roll that, and I got a 2, and I can roll it again and get another 2. Oh, I got a 5 that time. I got a 2 that time. Interesting. Maybe I'm not rolling it very good, am I? I got to really like wind up, shake it in my hand. 4. 4. I'm not shaking it very well, am I? Or I'm just like 2 and 4 day. Okay, there's a 1 that time. So we're familiar with coins, dice, deck of cards. Right? I've got 52 cards here. 2 different colors, 4 different suits. 12 of each. Is that right? 12. Ace through 10. No, 13 of each. I lied. Ace through 10, and then Jack, Queen, King. Other things we use with probability are spinners. We got a spinner activity, and one way to make an at-home spinner is take a paper clip and a pen, put your pen in the middle of that spinner there, and then just flick it. I got a 9. Flick it. I got a 5. Flick it. I got a 5 again. Right? Can you see? I got a 5 there. So a few different things that we're kind of familiar with to simplify the idea of probability. And some of these are used in life often in games, for example. And then sometimes we like, you know, flip a coin. You get to do the laundry, or do I get to do the laundry today? You have to wash the floor today. Let's flip a coin. Sometimes we might even draw straws. Straws, you've heard of that before. Let's go back to share screen. So some situations are simple enough where we can look at it, we can easily measure the probability. So for example, let's just think about flipping a coin. That's one that's pretty easy to do. So measuring probability. Case number 1, flip a coin. And the options of flipping a coin are we could get a head, or we could get a tail. And when you list all the possibilities, that's called your sample space. And so I usually put it in curly brackets, all the possibilities. This is the sample space. And sample space is just a list of possibilities, all possibilities. And we might even say the word outcome is used a lot. Something will happen. What happens? What happens is the outcome. The outcome here is either a head or a tail. And we often believe, so we have some assumptions here, beliefs, assumptions. Assumptions are beliefs. The coin is fair. meaning a head is just as likely as a tail. When you have outcomes that are just as likely as the other, they're called equally likely outcomes. So if these only two outcomes are equally likely, and the best a probability can get is 100%, right? So what's the probability I'll get a head or a tail? Well, I have to get a head or a tail, so that would be 100%. So just note, probability of a head or a tail, those are the only two things that can happen. That would be a probability of 1, which sometimes will state as a percent, 100%. Since they're equally likely, right, because this is fair, then that means the probability of a head has to equal the probability of a tail, meaning they have to split this 100%. So that means they must be 50% each, which could be written as a fraction or a decimal or a percent. So with that in mind, I mentioned earlier I chose to do probability next instead of statistics because probability is all about fractions, ratios. And in general, that measurement comes from taking a look at what we call favorable outcomes, so counting them. Count of favorable outcomes divided by a count of all outcomes. So if I want to get ahead, then there's only one way to get ahead. There's one head, right? So there's 1 for my numerator. And then how many outcomes are there total? Well, a head or a tail, there's 2. So here's my 1 over 2 for that. And we can make the same thing happen for a 6-sided dice. So that's another example that's easily measurable. So 2, welcome Julian and Montse. Dice. Most common type of dice we see is 6-sided, but there are many other types, 4-sided, 8-sided, 10-sided, 12-sided, 20-sided. I used to have a 100-sided one. That one was cool. Somebody borrowed it and never gave it back. I haven't found a new one. So a 6-sided dice. So the sample space for a 6-sided dice is typically, but not always, there are different kinds of 6-sided dice out there. It's usually a 1 and a 2 and a 3 and a 4 and a 5 and a 6. And like I showed, the one I had in my hand a minute ago, they have pips on them. There's little dots, right? So there's either 1 pip or 2 pips or 3 pips or 4 pips. Don't ask me where the name pip comes from. I've just heard them called that before. So if I wanted to know what's the probability of rolling a 3, we usually abbreviate that with P for probability, parentheses 3, and hopefully in the context we realize that it's a 3 on a 6-sided dice. Well, there's only 1 3 on the dice I just showed, and there were 6 possible numbers, so it should be 1/6. Now, since 6 isn't just a 2 or a 5 in the denominator, when I try to change it to a decimal, it gets a little messy. 0.16 and the 6 repeats. So that's kind of a pain. So I might approximate it and say it's 0.167, or as a percentage, 16.7%. So a fraction, if we can write down all the possible outcomes, we can exactly state a fraction for the probability. A percent sometimes is an approximation if the fraction doesn't make a nice decimal, and it doesn't this time. Now, not all probabilities are that simple, even though they sound that simple. So I'm going to put up another situation here that's simple, but not. Oops, if I can spell my name right. Gary throws free throws. Okay, so Gary throws free throws. Now, either he gets it in or out. So as far as outcomes go, right, my sample space, what can happen? Either I get it in or I don't. So we could say they're called in and out. And I'm going to change the camera again, and I'm actually going to throw some free throws. Let's see, we got it. Stop sharing. There's me. Let me see myself. There I am. Okay, so I'm going to set up. There's my chair over there. Here is my basket. My trash. Let's see, we got that there. And then for a ball today, I have my lovely orange snack here. And so I'm going to throw some free throws in there. Ready? Watch the chance. Ready? Oh my, I missed. Ooh. Okay, I'll get it this time, right? Because it's either in or out. So if I missed the first time, I got to get it the second, right? Isn't that the way it works? Oh my gosh, this is sad. Okay, what's the probability Gary gets a free throw? How about 0 based on this evidence? Ah, I got one. Okay.
Yeah.
Thank you so much for the enthusiasm. So based on that evidence right there, right, Gary has a 1 in 3 shot of getting a free throw. That's kind of sad, but true. I'm better with a soccer ball. Let's go back to share screen. So sometimes when we look at a situation, we might assume things are equally likely, but they're really not. And how do we really know? Now, it's usually a belief. That coin I was flipping, I got an awful lot of tails before I finally got a head. So in this case over here, these aren't equally likely. And you might say, well, he was just nervous because he was on camera, and let's give him a real basketball at a basketball court. Well, if they were equally likely there, then me and any NBA player, put us together, we get the same chance of getting it in. I might as well play in the NBA. I'm pretty fast, agile. I don't think so. So this is a lot more complicated situation than the coin, which had 2 outcomes. We had a belief with the coin they were equally likely, but in this case, did I clearly show they're not equally likely? No, I only did 3 tries. You could flip a coin and get 3 heads in a row, right? That happens. So what happens and the probability of an event are 2 different but related things. And we'll get to how they're related in a little bit. So this isn't like the coin situation where I can just look at the situation and say, oh, these are the probabilities. The only way to know this one is through experiment. So these probabilities can only be found through experimentation. So we just have to watch it happen over and over and over. We have to just keep repeating this experiment. And every time we repeat the experiment, it's a trial. So then I would end up with this table, this spreadsheet. So I would have a result and I would have a trial. So for example, a moment ago in my first trial that we observed, let's say a 0 is not in. So that's an out, 0, and a 1 would be in. So trial 1 was a 0, trial 2 is a 0, trial 3, I finally got it in. And let's suppose I'm fairly consistent, and so trial 4, I'm gonna miss it. Trial 5, let's say I missed it. Trial 6, I'm getting nervous, I'm gonna miss it again. Finally in trial 7, I get it in. I'm on a roll though, trial 8, I get it in, right? We just have to watch it happen. Right. If I only did 8 trials and these were them, then the best you could say is the probability that Gary gets it in, based on just those 8 trials, would be there are 1, 2, 3 ins out of 8 total trials. So Gary has a 3/8 chance of shooting a free throw and getting it in. On the other hand, as far as it not being in, it's out, right? There's 1, 2, 3, 4, 5 ways that can happen. And this always has to be true. The total probabilities of the individual events, they have to add up to 1. So often these are called simple events because there's only one way it can happen. So sum of simple events is always 1. There's only 2 simple events here, the probability of in plus the probability of out is 3/8 plus 5/8, which is 8/8, or 1 or 100%, right? Something happened. These are only 2 things that can happen. So what's the probability that something happens? Hey, it's 100%. What's the probability nothing happens? Well, that's 0%. Something always happens. Remember, probabilities have to be 0. Anything up to 1 can't be bigger than 1, can't be smaller than 1. This idea of simple event, I mentioned it, but I didn't write it down. Let's make that clear. A simple event cannot be broken down into other simpler events, other smaller events. Cannot be broken down into other events. So as far as the free throw thing, there's only 2 events, in or out. It's not that complicated.